The Java platform is in full bloom. There are many projects in the OpenJDK that aim to improve Java in some way. Some of them are already integrated or are being integrated, such as Project Loom, for instance. Some of them are ripening, and their integration is just around the corner. So let's look at 4 OpenJDK projects to look forward to. Java applications can take several minutes to warm up and reach peak performance. In addition, they have a bigger CPU and memory footprint during the warm-up. Project Layden will improve these issues. The project aims to shift some computations and optimizations from the runtime to some earlier stages, such as training runs. The shifting, constraining, and optimizing transformations will be applied in the form of condensers. A condenser transforms program code without breaking the compatibility with the Java platform specification. When the application runs in production, it reuses this transformed code, and so the startup is faster. Project Layden will use application class data sharing, ahead-of-time compilation, and some additional techniques that will allow the transformation and reuse of the application code. Early access builds of Project Layden are already available. At this stage, the project observes application behavior during the trial run and performs some computations. Then it creates a CDS archive with class metadata, method profilers, and some compiled code. If you want to try using early access builds of Project Layden with your application, I wrote a step-by-step guide on how to do that, and the link is in the description box below. Project Valhalla aims to improve the performance of Java applications by bridging the gap between the Java programming model and modern hardware capabilities. Java is based on the object-oriented model. So, if there is no available primitive type for some data, it is natural to use objects, but creating and fetching objects is costly. So, Project Valhalla will offer a solution in the form of value objects, primitive classes, and specialized generics. Value objects have a value and behavior just like other Java objects, but they don't have identity. Identity distinguishes objects from each other, helps to create mutable objects, and perform some identity-sensitive operations, such as comparing objects for equality by reference. But identity requires that an object resides in one place in memory and has a pointer. A value object without identity has to be immutable, but in turn, the JVM can freely copy and re-encode it. It leads to optimized memory usage. Primitive classes combine the benefits of primitives and objects. Their objects can have fields and methods, but these objects are only sequences of non-static fields, and they behave like primitives at runtime. Generics specialization will enable the developers to use generics not only with objects, but with primitive types and value objects also, without breaking the backward compatibility. All these enhancements will enable the JVM to produce more memory-efficient data structures, bringing the performance of Java applications to a new level. Early access builds are available for experiments. Babylon project will help to transform Java code into foreign programming models, such as GPUs, machine learning models, and so on. This will be done by improving Java reflection capabilities with the so-called code reflection. Code reflection means that the developers can write code models in Java that can be accessed at compile time or at runtime. These models can be transformed by Java itself to fit some other programming model. For instance, a Java program can be transformed into a GPU kernel or emulate language-integrated queries of C#. Project Babylon is at the early stages of development, but you can explore the documentation. Project Lilliput will reduce the size of Java object headers. All Java objects have headers, which consist of a header word and a class pointer. Hotspot JVM headers take up 128 bits on a 64-bit architecture. Project Lilliput aims to reduce their size to 64 bits, or even to 32 bits in the future if possible. This will help to improve memory footprint and CPU usage of Java applications thanks to the reduced heap usage. If you want to know more about the latest Java features and the development of the Java platform, subscribe to Bellsoft's blog. The link is in the description box below.